Hi friends, good morning. Today we are going to another section of general mechanics. Last class we seen what is centralized potential, how we represent energy potential function for a centralized motion. At the same time we seen radial and angular part of the centralized motion, See, so we have seen this equation, the force part, centralized force, for its radial part we represented as m into r double dot minus r theta dot square, this is we written. Alright, now this I am expanding as f of r is equal to m into this r double dot I can write as d square r by dt square. Am I right? Alright. Minus mr into, at the same time we know that the angular momentum J is equal to mr square theta dot. Am I right? So mr into this theta dot I can write as, so first of all I am writing this is mr theta dot square. Now f of r is equal to m into d square r by dt square minus mr into this theta dot I am writing j by mr square. What is theta dot here? J by mr square. Am I right? So I can write here j raised to 4 divided by theta dot j m square r raised to 4. Theta dot square I taken. Now what I can say, f of r finally what I can write, m d square r by dt square minus j square by mr cube. This cancel r, So this is very important. I am writing here f of r is equal to m d square r by dt square minus j square by mr cube. Alright. Now what is d theta by dt? See, d theta by dt is, that is theta dot. I am erasing this for a time. Keep this relation here. Now again we studied this theta dot is equal to j by mr square. What is theta dot? D theta by dt is equal to j by mr square. Am I right? So d by dt I can write as d by dt. Alright. So d by dt of is equal to j by mr square into d by d theta. D by d theta. Can I write like this? See this theta here, So d by d theta. Alright, see this differential of this I can write as d theta by dt conventionally. D theta come here, dt here. This I am changing as, I can write as d by d theta divided by dt by dt. D by dt. This only actually, or you can write it d by dt divided by d by d theta by parametric form. Then d theta by dt only this. Understood? So this part I am taking to this side. This part I am changing like this and this part I am taking to this side. So generally we can write like this, is in an operator form. So now this operator I am working with C d by dt of, I am writing dr by dt here. Simply I am plug in dr by dt. Then what I can write is j by mr square into d by theta d theta of, what is dr by dt? Dr by dt already we seen, dr by dt, suppose here you put r, here you put r, then dr by dt what? It is j by mr square into dr by d theta. Then j by mr square into dr by d theta. Alright. So this operator, right, before putting this this operator I taken. This operator I put dr by d theta. Then this side also you put dr by d theta. Then dr by d theta I put again. This is dr by d theta here. Understood? Now look here, d by dt, right? So this I can write as d square r by dt square. Am I right? J square divided by, right, m square r square. Can I write m square? This m I am taking out, m square r square, and this j taken out j square. So 1 by r square dr by d theta. D by d theta of 1 by r square dr by d theta. Alright. Again, d square r by dt square equal to j square by m square, right? So I can write like this, j square divided by m square r square, right? This 1 by r square dr by d theta I can write as minus of d square by d theta square of 1 by r, right? Because first differential of 1 by r what? Minus 1 by r square into dr by d theta. 1 by x differential is minus 1 by x square, you know, right? Using that property, 1 by r differential is minus 1 by r square into r on doing dr by d theta. So first double derivative of 1 by r I can write. Now for convenience I am writing this in different way. See what I can write here. My f of r is equal to, see this f of r. This f of r I am writing m into d square r by dt square. Am I right? D square m into d square r by dt square minus j square by mr square. This dr square by dt square, instead of this d square r by dt square I am substituting this. Then what I can write? M into this part I am writing j square divided by m square r square, right, into this minus become here d square by d theta square 1 by r, right, 1 by r, alright, minus this part j square by mr cube, right? Now we can do some substitution. I am taking u as 1 by r, right, in this expression. Then I can write as, see, f of r is equal to, see here this m 1 by r square I am writing u, 1 by r I am substituting as u. Then what I can write? J square by m, u square d square u by d theta square, because 1 by r is u, then d square u by dt square. Here j square m is there, j square m by minus, here one minus also there, right? Then 1 by r is equal to u, right? So here 1 by r I am writing also 1 by r square u square. Then this m cancel, then minus j square 1 by r square u square d square d theta by u square, right? Here 1 by r cube, that you can write as u cube, right? Then what I can write? Minus j square by m u cube. Then what I can, f of r is equal to, right, over r is 1 by u, then f of 1 by u I can write as f of 1 by u is equal to, I can take minus j square by m u square out. What is d square dou square u by dou theta square plus u only inside, right? This minus j square u square by m dou square u dou theta square plus u. This is the differential equation of a orbit of centralized motion, right? Orbit of centralized motion. All right. So this equation is very important. All right. So that is this equation, minus j square u square by m d square u by d theta square plus u equal to f of 1 by u. All right. All right. Now let us see one question. See here, a particle of mass m, angular momentum L, is moving under the action of a central force F of R along a circular path of radius A as shown in the figure. The force center O lies on the orbit. Right. Now, how the force is depends on this R, that we can verify using this equation. Already we derived this equation, d square u by d theta square plus u minus m into minus m by L square u square. This L means we already seen this is J, angular momentum J, right? L. So what we studied, the same equation, minus J square, right, u square divided by m into d square u plus, right, d theta square plus u is equal to f of 1 by u. Okay, this is what is we studied. Now this side we taking to that side means you can write like this, where u is 1 by r, right? All right. Now from this figure what you can write? You can write, see, this is the centralized, this figure is given. So this is a, then this diameter is what, 2a, this angle is theta, then what is this? This is r given, then this is 2a sec theta, 2a cos theta, am I right? 2a cos theta, adjacent side. So we can write r is equal to 2a cos theta. Now taking reciprocal, because in our equation u is 1 by r, then 1 by r is equal to 1 by 2a into 1 by cos theta is sec theta, right? So 1 by r is equal to sec theta by 2a, am I right? Now we make it is in another form. See, this is our equation, minus j square u square by m d square u by d theta square plus u f of 1 by u. Now we can substitute that value. See, what is our 1 by r, right? 1 by r is equal to u is equal to sec theta by 2a. Now what is du by d theta? Du by d theta is 1 by 2a sec theta on differentiation, sec theta tan theta, right, with respect to theta. Again d square u by d theta square u do means 1 by 2a into, right, tan theta first function, sec theta on doing, again sec theta tan theta plus, right, now tan theta you keep here, right, first function tan theta you keep here, this is first, this is second. Now second function sec theta into tan theta on doing sec square theta. Okay, now what is d square u by d theta is d square u by d theta square, that is sec theta, right, 1 by 2a outside sec theta tan square theta plus sec cube theta, sec cube theta, am I right? So that value only he they substituted here, minus j square u square, this is u only, right, 1 by r is u, then it's a square, u square means sec theta by 4a square by m into d square u by d theta square, we already seen 1 by 2a into sec theta tan square theta plus sec square theta sec cube theta, that substituted, and plus u, again this u is sec theta by 2a f of 1 by u, right? Now substitution we made. Now further simplification, right, what you can write, j square sec square theta by 2a square by m, right, 1 by 2a, 1 by 2a you can take a common denominator here and here, then here sec theta tan square theta sec cube theta, here plus sec theta f of 1 by u, again minus j square 1 sec theta you take out from all, then sec theta gone here 6 square, here 1 varu, so 1 tan square theta sec square theta f of 1 by u, then minus 2j square, see sec cube theta. What is sec square theta plus tan square theta? Right. See, tan square theta is equal to sec square theta minus 1. Okay. So tan square theta, you write sec square theta minus 1 means this one cancel. Then here 2 sec square theta. Sec square theta into sec cube theta, what? That is 6 raised to 5 theta. Right. Then that 2 come from this 2a here. Right. This 4a square, 2a the whole square here. This 2a we taken out here. Right. Then finally you can write like this. Then what is f of r? 1 by u is equal to r only. Then f of r proportional to sec raised to 5 theta. Sec raised to 5 theta means what? Sec raised to 5 theta is equal to, from this equation, what you get? 2a by r whole raised to 5. That is proportional to 1 by r raised to 5. So f of r is proportional to 1 by r raised to 5. That is the first part of the question, how this potential function, right, for this particular motion described here in such a way, this r is equal to 2a cos theta, how the force, centralized force relating to radial part of the force related to radius, that is f of r is equal to 1 by r raised to 5, right. Next case, second part is calculate the total energy of the particle assuming that a potential energy tends to 0 as r tends to infinity. Now centralized motion, what is the energy we seen? See, it has a energy has a radial part half mr dot square plus j square by 2 mr square plus v of r, right. Now in the question they given r tends to infinity. R tends to, this is the energy, right. So this is energy expression we already seen before previous lecture, and r tends to infinity means the second part becomes 0, right. This j square by 2 mr square tends to 0 as r tends to infinity, and also v of r also tends to 0. V of r also tends to 0, right. R tends to infinity because potential is the inverse function of radius, right. So once the potential varying, this r tends to infinity means potential function also 0, right. So energy is equal to what? Half mr dot square, right. Now but r is equal to what you studied in the question given 2a cos theta. Now what is r dot? R dot is equal to 2a into cos theta on differentiation minus sin theta, theta dot, right. Alright. Now what is theta dot? We already studied mr square theta dot is equal to j, right. Mr square theta dot is equal to j, angular momentum mr square theta dot, right. Then what is theta dot? J by mr square, alright. J by mr square, alright. So by substituting that value, see, by substituting this value, r tends to infinity. What about theta dot? Theta dot also tends to 0 because denominator tends to infinity. So we can say if theta dot tends to 0 means r dot also tends to 0. R dot tends to 0 means what about our energy? Finally remaining this radial part of energy half mr dot square only. R dot tends to 0 means energy also tends to 0, right. So the second part of the equation, energy tends to 0, right. Alright. So this is all about this section. Next section we study about Kepler's potential and Kepler's laws of motions. We have 3 laws of Kepler's, right. Alright. Thank you.